I think perhaps, okay, so let me start. So right now, we finished the discussion for timing, right? And then we can have the next one. Here, this is arrive. Well, you guys think about this, arrive. So that says we need to follow the arrangement of arrive. And actually completely implement the flow chart for arrive routine. So is it true? So first of all, let me get back to arrive first. Arrive here. So I quickly go through this one. Arrival event, schedule the next arrival. Check-in server busy or not. If yes, and then increase the queue size. And the check-in, the queue is full or not. Wait a moment. Seems to be something wrong, right? I still ask you guys, can you hear me properly? Okay. Okay, thank you. I got it, no problem. Maybe some fluctuation of the Wi-Fi status. So that's why I worry about something wrong. All right, so we have the left-hand side branch, and also we may have the right-hand side branch. And this one, I just ask you guys to have the direct copy. Or maybe you can take a snapshot here, and later you can use your snapshot to check, is it true? We can use the current flow chart to have the source codes for arrive. All right, I just let you guys know we will implement arrive. All right, so yes, we use that flow chart to understand how to have the codes here. All right, so we have a delay. So we have a delay. If you fail to hear me, maybe just let me have a message and then I can try to check anything wrong or not. All right, so we have a local variable delay. Okay, so that's why we need to declare delay. And this is a right, so time next event 1, right? Time next event, talking about the arrival event. So this one, it is a single event for the next departure. Sorry, not next departure, next arrival. Schedule next arrival, right? All right, so this one, schedule the next arrival. Am I right? If you guys want to check this one. And furthermore, check-in server busy or not. This time, I think you guys can use your own copy to check it's true. If busy, right? If idle. Okay, so we may have these, busy or idle. If the server is busy, right? So you need to join the queue. Join the queue, so increase the queue size. All right, and next one, try to check. Queue size exceed the queue limit or not. If yes, then you need to have the message overflow of the arrival at when actually the time instant here, and exit to the same abnormally. So we exit using 2 to show abnormally. And then if everything's okay, then when you have the time arrival, okay, so you just use the time. Okay, so join the queue using the current time. That says the simulation time. If you have idle, then you have a 0 for delay. And total of delay, you simply add the current delay, even it's 0. But this is a 0 associated with the direct entering situation. All right. So this is the set 0 and set get the total delay. The previous one, maybe you don't have these, but this one actually should be get. Okay, should be actually should be got. So we have these, and we need to increase the sample size and switch the server status to busy. Okay, and schedule these. All right, and schedule the departure. How to do? 2 means departure. So the current time plus the mean service time, and so that you can schedule these. And update statistic. So here you have update statistic. Only for this one. Only for delay. All right. So update statistic only for total delay. And then that's done. And nothing else. And nothing else. Look at this. If we have the arrival and first arrival, think about this. This is the previous event. And you may have an area. Right? For arrival, of course, you may have an area. So that's why before processing the arrival, you need to update area of time statistic. So that's so that's why previously we should have the update time average statistic before, at least before arrival. So update the statistic before arrival. So that's why we have the position before arrival and also before departure. So you can have the position for update time average statistic before arrival and departure. All right, so this is arrive. Is it okay? If you have any question, just let me know. And next one, we have the departure. Same, I go back to depart. All right, so this is departure. I think you guys can go through this quickly. Departure, checking the queue empty or not. And if empty, then we change the server status from busy to idle and eliminate the departure event. All right. And that's all. Okay, so if you want to have the reference, you just take a picture, and so that you have a snapshot for the routine. And then we follow this routine to have a depart. The same. Check-in status. Check-in queue is empty or not. So empty. Not empty. So empty, what to do? Switch status to idle and eliminate this one because no one joined, so no departure. No departure, so the departure to the infinity. All right, so this one, you should understand this. No departure. Don't forget to set the departure to infinity. And if not empty, then we need to, you see, not empty. Not empty, so you need to remove head of line. So double minus means -1. Remove the one in the head of line. And then you can compute the delay for this head of line. How to do the current time and time with the arrival. Look at this. Why it's 1? 1 means head of line, right? Head of line means the current arrival, the time instant of the current arrival. So using simulation time minus the current arrival. When to have the current arrival, then you have the delay. And again, you can accumulate a delay. And next one, sample size increased. And next one, schedule the departure. And next one, move customer in queue. Right? Here, how to move. Move each customer in queue up 1 place. So how to move up 1 place? This one. I plus 1 to I. Do you think the operation here suitable? The answer is yes, because head of line should be replaced. Okay, so you can move the second one to head of line. This one to head of line. So replace without any worry. So this one, okay, I plus 1, index I plus 1 to I, using the way so that no need to care about wrong operation. And then that's all. All right, so this is the flow chart of a repo. And let me check the status. So I still think everything's okay, right? Even I have some, maybe some tone to remind me, perhaps the connection with some possible problem. But I think that's okay, so let me skip. All right, so we follow the flow chart to implement arrive depart, because arrive and depart perhaps somewhat harder. So that's why we prepared the flow chart for arrive and depart. And I think you guys can feel everything's okay, right? Or maybe you still have some questions. So that's why I ask you guys to let me know if you have any question. You just stop me, and so that I can that you have the proper explanation if necessary. All right, so this is the routines arrive and depart. And the next one, we just follow the order to check repo. If everything's okay, then how to have the further message within the our file? It says delay. You may have a queuing delay, and you may have a queue size, and you may have the system utilization, and you try to understand when to stop because we use the upper limit of the sample size to stop the simulation. So the final message that you know when the simulation is ended. All right. Okay, so about delay, how to have a delay, really easy. Accumulated delay over the sample size. Finally, what is the sample size? Because we reach number customer delayed, right? Or maybe we can reach the upper limit, use that upper limit. But at least current number customer delay will be a safe number because sometimes maybe for some reason you may stop. Normally everything's okay. So the current number customer delay should be equal to the number customer required. The two variables should be the same, but the current one choose number customer delay to serve as the current sample size and actually the final sample size. And next one about the mean queue length. How to do area accumulated area over the time. So what is the time? The time reached. So we can use simulation time. And same area server status over the simulation time. And then you can have the calculation. So repo is really easy. You just use the accumulated quantity over the required sample size or over the time required. And that's all. So here we show you the average delay and show you the queue size and show you the system utilization. Well, that's all. We still have the task to do. What is the task to do? That's this. Update time average statistic. How to update the time average statistic? You see, if we take the first arrival as an example, this is the time-lapse event. So time-lapse event and current time. Current time is the simulation time. So use the simulation time minus the time-lapse event. Then you have time since last event, right? If you do so, and then you need to move time-lapse event to the simulation time. Actually, time-lapse event related to the function only, not to arrive depart. So no need to care about time-lapse event update may alter the normal operation of arrive and depart. So don't care about this. So this one, okay, you can use it. Once you have this, for the remaining, it's really easy. You just add the extra area to be accumulated. So number in queue, time-lapse event, server status, time-lapse event, and that's all, right? For the number in queue, I think not joining the queue, so that says the current number in queue, no problem. But server status, actually the previous one, so no update. So up to now, I think server status representing the status before the current event. So the same, okay. So they are the previous status and the previous number in queue. So everything's okay for the update. So that says it accumulated the area. All right, for queue and for server status. So everything's okay and no problem. And that's all. All right, so about the update time average statistic, is it okay? If everything's okay, then you see Finally, we have exponential, and everything's okay for the codes. I think you guys can download the codes from the website of the task force. You can rewrite the codes according to the task force. And then I think you have almost all. Why I call almost all, don't forget you still have a LCG random. The file should be put into the current directory, and so that you can call the function LCG random. So don't forget you still have the function LCG random to employ. All right, so this is the discussion for source code 1. Is it okay? All right, so if you think okay, and then you use the action, raise your hand so that I understand you guys understand this. Can you do so for me? Someone like raise your hand, and so that I understand everything's okay, and I understand the current operation for the Skype is still okay. Okay, go ahead. Raise your hand, and so that I can see everything's okay. Something wrong? Oh, sorry. Not really easy for me to see you guys raise your hand. So thank you. I got it. All right. So next one. Next one. We need to try. We need to try if we run the simulation. Wait a moment. Let me check my phone to see can I see any message. Well, maybe not really easy. Okay. But at least I see you guys raise your hands, so I think the system is still okay. So I try to continue. Remember, this is the output. This is the output. So previously, in the main file, we have the preparation. You can have the setting in the in file. Parameter 1, parameter 0.5, and the number of customers, 1,000. And here, minutes, actually, it doesn't mean you need to have the unit minutes. In fact, you can have a unit second or millisecond. You can alter the unit. So even you don't have any unit, that's fine. It's a unified unit. So you can change it to minute, second, millisecond, or the others. And so that you have the output, average day in queue, average number in queue, server utilization, and when to end the simulation. The same, you have the same unit. So of course you have units again, right? All right, so you need to prepare a file, the in file. And so that you have the measure. So this one, you should have the in file. Okay, so that says you should have a file. All right, the file actually refer by the main function, and actually this file is called the in file. All right, so you can try to perform the simulation using these. Before we continue, let me remind you all of these. For MN1, actually we can have the so-called traffic load. Perhaps we have a row. Row actually should be this. This is the arrival rate. This is the service rate. Okay. For the arrival rate, actually you can use this arrival rate. So 1 over lambda, actually the mean inter-arrival time. And this one, 1 over mu actually is the mean service time. Okay. Why I remind you all of these? For MN1, when we have the stable system behavior, when rho lower than 1. Lower than 1, so this one means lambda lower than mu. Imply right? So that says mean inter-arrival time should be greater than mean service time. So that's why larger, smaller, right? Okay, so about this one, I have an extra reminder for you guys. You can refer to the description of Google MN1 queuing system, stable, and you will understand rho smaller than 1. Once smaller than 1, you can have the condition. Arrival rate should be lower than service rate. If we use rate, you can understand this quickly. Service rate, that's a service capacity larger than the arrival rate. So of course, server can have a higher capacity to finish all the customers. And using this, you can have lambda lower than mu implies 1 over lambda greater than 1 over mu. Here, mean inter-arrival time greater than the service time. What that means, you can use your service rate so that you can serve quickly, but the customer comes slowly. Customer comes slowly. That says you take your time to serve the customer. So don't care about everything's. I mean, you just have the everything's okay. You don't care about anything wrong, right? So this is really important because if you fail to have the proper setting, then you don't have the stable result. If you don't want to have a stable result, then what happens? If you measure the delay and you measure the number in queue, then you may have, I mean, how about this? Rho greater than 1. Rho greater than 1, then unstable. Unstable measure. Unstable measure indicate you may have the different values in delay, different value in queue size. Okay, And for server utilization, even not the fixed value, but at least more than 1. However, average number in queue perhaps greater than 1 or maybe a really large. Delay, yes, a really large. Okay, that's it. So this is a comment for you guys for the parameter setting. I think you guys copy these, right? And these are really important. And these you need to keep in mind. Mean inter-arrival time larger than mean service time. For such a setting, allow you to have the stable results, or otherwise not okay at all because you don't have the stable results. All right, so this is the setting for parameter. Is it okay? So at this, mean inter-arrival time larger, mean service time smaller. As for the unit, you can alter them to different unit. So it can be second. That's okay. It can be millisecond. That's okay as well. You need to have the consistent unit, and then that's okay for you guys. All right, so this is a source code for version 1. And also, this is a possible setting for running the simulation. I think okay for you, right? If okay for you, data check further. 3 digits, right? But for decimal point, I mean, the left-hand side of the decimal point, you only have a 0. Never mind that one, but 3 digits for right-hand side of the decimal point, 3. Why? You see? 3 and 3 and 3. Finally, it's 3, right? I just trying to emphasize the precision. You should have 3 digits on the right-hand side of the decimal point. But for the right-hand side, because large enough, so single consume 1 digit. So you cannot see the whole, all the digits are occupied. So you simply have a 1. Sometimes maybe you have 4, but at least lower than the precision. So the same, 3 for time ended. All right, I just try to emphasize it's true. You can specify the precision digits, and so that you can understand you only show 3 digits after the decimal point. And you may have more, but right now you only see 1 and 4 digits. In fact, you may have large enough digits. So that's why no limitation at this moment. All right, so this is the first version. Is it okay? If it is okay, right now, let us switch to the second version. For the second version, I just go through quickly and try to emphasize where you may have the different arrangement for version 2. So up to now, almost okay, right? So no change. And main function, is it true? No change here. 3, because you need to have the extra 1. One for ending the simulation. Okay, So what kind of ending the simulation? This one. End simulation event type 3. This one. End. So once reached, so you just have the report directly. So this one, end the simulation. So finally, just provide the report. All right. We also alter these. Do using do while. Why? Because if the event type is not 3, and then we need to run simulation. Unless the event type is 3, and then we need to stop. Stop and then everything's okay because you reach event type 3 and break, and finally this one need to finish and then you can close the file and return 0. Okay, so we need to define end simulation event. All right, so how to define end simulation event? If I do not mark, and then this almost the same, but look at this. For time next event 2, it is infinity. So no departure. Right? No departure. But for event type 3, we have a time end. So maybe go back to check. No change, I should have the correction. Where we have a time end, this one, I forgot to that. You guys know that. This one. So you need to specify time end. Okay, so that's why I go back to cross these, and so that you guys can understand, we need to have the specification within in file when to end the simulation. All right, so you have a time end within the in file, and the others the same. And for report, no change. Maybe not no change. For report, here you use these. How many, how many customer collected to reach the average delay? And for this, you see, the same. But, yeah, the same. The final one use number customer collected. What? Let me check the previous one. Here we use time. And this one, we use number of sample size. All right. Why we do not show when to end? Because we specify when to end, so we don't care about when to end because this is known information. But number of delays completed here, it's an unknown information. It's the unknown information. So that's why we want to know. For our simulation, we have 475 for the simulation. So that's why we want to show the information. And that's all. This is version 2. And next week we can continue. And next week we can let you guys know if we want to alter the codes here to collect, for example, system time. And what is a possible way? I just want to ask you guys to think about that. But I think at least you need to review the codes here so that you can totally understand the codes associated with MN1 to measure queuing delay, to measure queue size, to measure system utilization. So I think at least you guys need to understand the codes here. I think that's all. Any question? If no, I stop here and call you a day, and let us have the discussion next week. All right, if you finish the registration, and then see you next week. If you don't finish, don't forget to finish the registration before 11:25. All right, see you. Bye-bye.